Let's look at types of compounds. We have binary ionic compounds, and a binary compound is just a compound that contains only two elements. Remember, the prefix bi, as in bicycle, means two. So a bicycle has two wheels. Binary compounds have two elements. More than one ion of each element, but not more than two types of elements. So sodium chloride is binary. Magnesium chloride is binary. Calcium fluoride is binary because it only has two types of elements. So are these binary or not? Take a pause, try to answer these, and then come back to see if you are correct. All right. So sodium chloride, this is yes, it is binary. There are just two different types. Beryllium bromide, that's also a yes. There are just two different types. Aluminum oxide, yes. Sulfuric acid is a no. There are three different elements in there. Nitric acid is a no. Potassium iodide is a yes. If there are only two different types in there, it's binary. If there are more than two different types, it's incorrect. So let's learn how to name ions. And once we learn how to name ions, we can start naming binary compounds. So we know cations are the positive. Remember this positive T right here indicates that it's positive. Cations are identified simply by the element's name. So potassium ions becomes the potassium cation. Magnesium ion becomes the magnesium ion. The cation is just the element's name. Anions are different though. The ending of the element's name is dropped, then IDE, ide, is added to the root name. Fluorine becomes fluoride. Nitrogen becomes nitride. Oxygen becomes oxide. I'm trying to think of other nonmetals off the top of my head, and I'm drawing a blank. I need the periodic table here. Sulfur becomes sulfide. Bromine becomes bromide. And then we've already mentioned fluoride and chloride, phosphide. So just remember, nonmetals will end in "ide." So ions have charges. Group 1 ions have a +1 charge, remember. Group 2 has a +2 charge because in group 1 they have one valence electron. They'll lose that to become a +1. Group 2 has two valence. They'll lose that to become +2 charge. Group 13 is going to have a +3 charge. Group 14, if there are any metals in group 14, it's going to be a +4. Group 15, depending on the element, it could have +5, +3, or -3. We're going to be looking at these elements here primarily. We're not going to be looking at antimony, arsenic, and bismuth. We're going to stick to nitrogen and phosphorus, which will give us the -3. But just so you know, these are possibilities for group 15 because you have a mix of elements. You have the post-transition elements, you have the metalloids, and you have the nonmetals. The nonmetals will become your -3 charge. Oxygen is in group 16, so group 16 elements here are going to gain 2 electrons to have a -2 charge. Fluorine is going to gain 1 to be like group 18 and have a -1 charge. To name a binary ionic compound, you're going to first write the name of the positively charged ion. A cation always comes first, and usually that's a metal, not always. Then you're going to add the name of the negatively charged ion, but you remember that ending gets to be changed to IDE, to IDE. The sum of the charges in an ionic compound always equals 0. We know that the sodium ion loses 1, sodium atom loses 1 electron to become an ion, and it will have the +1 charge. Chlorine gains an electron to become a -1. We add a +1 and a -1 together. The sum of the charges is always 0. Now, when you write a formula, you're going to add subscripts to the symbols for the ions until the algebraic sum of the ions charge is 0. The subscript tells us how many ions are present. Here is an example. We have calcium bromide. The easiest way to write your binary ionic compounds is to write your ions with their charges. Then you're going to swap the superscripts, so the charges, and make them your subscripts. So calcium would have 1 subscript, and if it's only 1, you don't write 1. And bromide would have 2. So it's CaBr2. If we want to check, we're going to say, well, we know calcium has a 2+ charge. So this is, it'd be 2 times 1 plus bromide has a -1 charge times 2 bromines. And this is 2 plus a -2, which equals 0, which means this is the correct formula. Remember, if there are ever any questions, let me know. Now, what would this name be? Remember, you name the first atom first, calcium, and the anion is the same except for the ending is changed to IDE. So its name is calcium bromide. Now let's look. How would we write a formula between aluminum and iodide? Well, if we look at the periodic table, aluminum is in group 15. No, sorry, it's in group 13 if you look at it. So it would lose 3 electrons to become aluminum 3+. Iodine is in group 17. It will gain 1 electron. Now, if we do the cross and drop like we did before, we have aluminum, and there's just 1 of those, and we have 3 iodides. So if we were to name this, it would be aluminum iodide. You always change the ending to IDE. Now, the subscript, as I mentioned before, just tells us how many ions are present in the compound. We have calcium fluoride here, which means we have 1 calcium and 2 fluoride atoms. In an ionic compound, the formula represents the smallest ratio of atoms or ions in that compound. In a covalent compound, the smallest unit represents a molecule. A formula unit then is the simplest ratio of ions in a compound. This right here is a formula unit. That's the simplest ratio of ions in that compound. Remember, ionic compounds don't have an overall charge. If we know the valence number, we can predict the charge of an ion. So we look and take a look at the periodic table, and we ask ourselves, which elements will lose electrons and which ones will gain them? Nonmetals will gain your electrons. So these right here, these will gain your electrons. Metals, so the majority are going to lose their electrons. Because metals have fewer valence electrons, it takes more energy to gain all the other electrons that they need to reach 8 than it would be to lose the 1 or 2 or 3 electrons that they have. Electrons take the path of least resistance. They're lazy. They say, you want me to work to gain 5 more so that I can be stable, or you want me to give the 3 up that I have? I'll give the 3 up that I have. That's easy to do. So metals, since they have fewer valence electrons, they'll give them up. It's too much work to gather more electrons. Most nonmetals tend to gain electrons because they only need to gain 1, 2, or 3. They have the majority that they need. It's easier for them to gain them. If you ever hear me say oxidation number, that just means the charge on the ion. And transition element oxidation numbers can't be predicted by group number. They have a very complicated orbital, like we talked about before, where the orbitals, sublevels are so close to one another that they can actually jump between the sublevels more easily, which means it's more difficult to predict their valence electrons or their oxidation numbers. Now, using your periodic table, what would the charge be on the following atoms? I want you to take a pause, try these out, and then come back after you've tried them. But let's go over them. Oxygen is in group 16. So it's going to gain 2 electrons, which means it's going to be a -2. Sodium is in group 1. It has 1 valence electron, which means it'll lose that 1 valence electron to be +1. Potassium is in group 1. It also is going to be a +1 because it'll lose it. Chlorine is in group 17. It's going to gain 1 electron to become chloride. Magnesium is in group 2. It'll lose its 2 electrons to become +2. For these practice questions, I want you to push pause and come back and try again, or check your answers, I should say. But let's look at these now. Write the formulas for the binary ionic compounds formed between the following. Now, one thing I want you to know is zinc, although it is a transition element, you can actually predict its charge. With the zinc and silver, they both actually have a set charge. They only produce one charge. That is rare for the transition elements. So silver is always +1 and zinc is always +2. So I do want to give you those. So whenever you have zinc and iodine, we know zinc is +2 and iodine would be a negative. You do the drop and switch. So you have zinc iodide. Now let's do zinc and sulfur. So you have zinc, 2 plus. Sulfur is in group 16, so it's going to be 2 minus. This one's a little tricky because if you did this, you get zinc 2, sulfur 2. That's not correct because remember, the formula unit is the simplest ratio. This is not the simplest ratio. So you'd have to simplify this to zinc sulfide. So no subscripts. Let's look here. We have aluminum, which is in group 13, so it's 3 plus, and nitrogen, which is in group 15, so it has 5, which means it would gain 3 electrons. This is balanced. These cancel each other out. It's just like zinc and sulfur. So this is ALN. And if we wanted to name it, this would be aluminum nitride. This would be zinc sulfide. And this one would be zinc iodide. Let's look at the next one between magnesium and chlorine. Magnesium is in group 2. It has 2 valence electrons. We lose them, so it's magnesium 2 plus. Fluorine is in group 17. We lose 1. It becomes, or sorry, we don't lose 1. It has 7 valence electrons. It gains 1 electron. So it's 1 minus. We do the switch. We get magnesium fluoride. We always change the ending to IDE. Now for number 2, you are naming the binary ionic compounds. AgCl. Ag is silver, so it's silver fluoride. Next one, BaO. Ba is barium. And oxygen, you just keep the ox part. It's like with nitrogen, you just keep the nit part. So it becomes barium oxide. Okay, let's look at this one. Ca is calcium. Cl is just like the Cl, it's chlorine, but we change the ending to chloride. So it's barium chloride. Here we have Zn is zinc, and O is oxide. That's it for today. I strongly recommend you practicing naming compounds, and I'll see you next time.